Okay, let's get started here. So this is a true labor of love for me because I'm on my fourth generation Spectrum monitor. And I think you'll like what you're going to see today because the latest version is online from my lab right to here. So what I'm going to do is all right, so first generation is, and if you're involved with amateur radio and so forth, these did not come up to be very popular, except when you were in the military or had access to a lot of the military equipment, surplus equipment. But when you want to look at a signal and analyze a signal, you had to do a receiver within a receiver. And that's the first generation. If I want to look at the spectrum and I want to do something with it, I had to actually have a receiver within a receiver. It said sweep the IF or the area of interest that would cover the frequency. And then what I call a second generation, this is Tektronix SDR. And this would do complete signals analysis of signals, and then it had built in the FDR demodulator. It had the typical vision. This is particular systems analysis of the signal itself on the spectrum. And then it had the software equivalent to persistence, so you could see the spectrum outline is average, and you see it retained like you would in a storage type of display, storage scope. Anyhow, this baby started at $6,500, and we wanted one. Trust me.
We all did.
I even had buddies in Tektronix say, "Can you give me a discount on it?" Yeah, we'll get you a couple hundred off. Oh, you wanted software with this? Now you're at 11,000. So this was so this was more my budget. So I tracked when Andre, the original author of Open Web SDR, came out with a Linux version of a Spectrum display. He did the same thing that Tektronix was doing, meaning he was remoting the user agent from the actual SDR, which means you could take this package and put it anywhere you want, which is pretty cool. So I started with the Linux version of OpenWeb RX. And that evolved, the software itself evolved into OpenWeb RX Plus. It wasn't a fork of the source code, but yet it's a long story. But anyhow, some German hams that did all this and did a great job. I worked with them on testing and doing some of their work. But anyhow, this is something I had used extensively on you can see the spectrum waterfall. You can see it demodulating actual, in this particular case, it was demodulating whisper, the SPR protocol. And the software is pretty cool, and we're going to spend a lot of time on the software. But that's third generation. Let's look at the fourth generation. I actually jumped it. 3.5, but so I had this working on a Raspberry Pi 3B, 3 Baker, and working quite well. Now, this was a server. This is a Spectrum server, so meaning it's placed out of sight, could be out of sight, could be placed right on the antenna, 30 feet up. It can be in a proper weatherproof housing. I could supply voltage and I get a full Spectrum display that I reach with my browser on a wireless link on either Wi-Fi or Bluetooth link. So the difference between this baby and a smaller Raspberry Pi, and this is not the 3B, but once it worked with the 3B, I says, hey, there's a Raspberry Pi Zero 2W, second version of Zero, and it's the same Broadcom processor. 5-core processor for $14. And I said, I wonder what happens if I load this Pi software, Raspberry Pi Linux modified software from my 3B to this puppy, burn a SD card and plug it in, and while it came right up, no problem. Because I was thinking, I'm sure I'm gonna have to overclock the processor, change the voltage level of the processor. None of that. Now, the difference between this and this, this, is I can put 20 users on this, which is an i7 processor. And I cannot put 20 users on that. I could do maybe, well, the authors went back and said it's not gonna work. I said, it's not only gonna work, but here, try it, you know, so. Sitting in Germany, all they needed was my web address, and they were looking at this thing and they couldn't believe it. So then one of the guys quickly grabs a Zero, puts it on, he goes, you're right, it's working. He says, we've tested it to 3 users, simultaneous users. So now I'm looking at a $15 DSP, handling a DSP. I put it from a V3 SDR hardware, and I'll talk a little bit about that. And now I can run all my open web RX Plus software on this little cute version. Low power, and there's a reason for that. I won't talk about that. And that's the antenna I've used it on. So this is a 20 to 1700 megahertz discone diamond J130 antenna on the top of my roof, over 30 feet up. And that's what I've been testing this with. So what we're going to do in this lecture, I'm going to go a little bit more into the theory and what you can do with it. But I have a live session with this specific unit in my laboratory, in my basement, running. So we're going to actually talk to this. And I'm going to request, you can request any spectrum you want. I'll show you how you can pull up any spectrum between 25 megahertz and 1700 megahertz. And you can demodulate one of over 30 protocols with this code, with this open web RX code. So having configured this correctly for the Zero, you notice one thing here. So it looks like you have 2 USB ports only. Well, you don't have that. So these are micro USB. The first one is power only. The second one is your available USB port. So first you're thinking, how the hell am I going to configure this thing? You know, I need a keyboard on it. Yeah, I can go SSH into it, but I want to actually talk to the Raspberry Pi directly. There's certain things you can't do remotely. And well, turns out I just grabbed the Y cable and plugged unplug this, plug the Y cable with a keyboard and output. I'm good to go, set everything up. So this isn't my final configuration, but I was able to configure it all through one port. Okay. Well, why they did that was brilliant. So they said, well, the most power on a Raspberry Pi is, what do you think it's due to? It's all the ports you got on it.
Yeah.
Yeah, you got a bucket load of ports on it. And
To save power, they only had one extra one.
Hey, we're going to give you Bluetooth, universal Bluetooth, and we're going to give you universal Wi-Fi on the Broadcom chip. We're going to use the chip that's quad core, 4 cores. It includes Bluetooth and so I don't know about you, but I love Bluetooth keyboards. You know, I got all my everything I got is if I don't even have a keyboard, I have at least a Bluetooth mouse because it's so convenient. You know, so if you think about it a little bit more, you could configure all your I/O through Bluetooth. But I was not patient enough to do that, so I just stuck a Y cable on, configured it all, and voila, the thing comes up. And then I plugged in my trusty USB stick, which is this one called a V3. I think I talked about it a little bit here. Anyhow, I plugged that in, and then I defined, again, the other side of this thing, I got the antenna on the roof. So I've got half of the equation here of the DSP function, and I've got the hardware dongle that you need. In any case, you need some kind of dongle that takes care of the RF sampling, the I and Q sampling directly. So you got everything here that's interesting. And so now I have Wi-Fi. So what you do is you configure this Wi-Fi chip to talk to your Wi-Fi network. piece of cake. So then at the same time, you get into your firewall settings and I know they all have them. You can get into, if you can, I don't know how to get it. Sometimes they don't want to tell you. Optimum didn't want to tell me anything. So I get into the router and then open up the firewall to pass the specific port OpenWebRx needs, 8073. It uses a port called 8073. And then I can pass everything from the internet outside into this puppy. And it all works. So one thing you need to do is identify this on the network. I use Nmap for that. And then once I got the IP for that, then I can get into the firewall setting and open the firewall. So here's what you get. I'll just give you a little of got the theory here. I'll go quickly through this. So again, this is a dongle that costs anywhere between $35 from Amazon. It's good because it's stable. It's not like the earliest ones that were cheaper, but they were that stable. What does it do? I'm sorry, what was your question?
Yes, I'm sorry. What does that board do? I see an antenna RF on the left and I see USB on the right.
Yeah, so that's a good question because what it's doing, it's directly taking an RF in.
From what band? From how wide?
From 20 megahertz to 700 megahertz.
Cute. And this is $30?
$30.
How come it's only $30?
Miracle of, this was originally designed for TVs.
Oh, okay.
But, so what comes in here is your RF. I even have a slide on that. There's a lot of good articles on it. The best one, I like IEEE a lot, and IEEE did a nice article on this experimenting with it. So this is what it's doing from a functional block diagram. You got the RF in over here with my pointer. So you got the RF coming in directly into your variable gain LNA, low noise amplifier. You filter, they call it a filter. It's not really a bandpass filter. It's this low pass filter. And then into an 8-bit converter. So it's got an 8-bit sampling device here off of this VCO. So it samples, they call it in-phase and quadrature. It sends out the sampled RF spectrum to your USB port, and your USB port I set the sampling rate inside the OpenWebRx Plus to be 2.048 mega samples. So then it's sampling in phase and quadrature. If you sample in phase and quadrature, I can do all the DSP work. I can do anything I want in DSP with the signals. If I record that spectrum, I can play it back and derive the waterfall. I'll show you all the stuff you can derive from it. But that's the front end. So that's the dongle. We call it the dongle affectionately. But it's 8-bit. There's better dongles with much wider sampling, which is good for dynamic range. So you get a really strong radio station next to you. This will wipe out because it's only 8-bit converter. The dynamic range is very low. So here's what's going on the sampling. You got your in-phase cosine and then your sine wave, and then you're sampling through an 8-bit converter. Now there's better one. Now I have a couple of these. These are real nice. These are a little bit more expensive. So these are $200, but what it gives you is an 18-bit sampling, PDA converter, and it has actual bandpass filters in front of it. So it gives you performance. I don't know how many of you are ham. Okay. So the performance, if you use this part right here, it's called an Airspy HF Discovery. It's pretty much the same as for Yaesu. You'll get almost identical or slightly better at lower frequencies than you get with. So these are really high quality. It's worth $200.
Yeah.
You got 95 dB of dynamic range versus an 8-bit, which is 55 dB of dynamic range. I mean, it's not much. Anyhow, this is what I have to. A little bit of what's that?
Could you go back to that? Or?
Yeah. Yeah. So this is the expensive dongle, the Airspy Discovery HF Plus. Airspy HF Plus Discovery. That's what there's a lot more filtering going on, so it's a lot.
Have you seen the Radio Pi?
Yeah, I haven't tested it, but
Yeah, I was just curious. I seen it, I just saw it the other day. I was just curious because it seems to be the whole thing built in.
well, this isn't that much.
Yeah.
It's tiny too. But here's the kicker on this. So your user agent is any web browser, any modern web browser. Why is it modern? It's got to be compatible with JavaScript. You got to have JavaScript running because it's doing all your user agent stuff, your client side. So what you're doing is streaming the INQ. It's processed with the DSP, but yet it's also sub-processed and displayed with all your user agent using your own browser. So every browser that's compatible with the JavaScript module, JavaScript. So then it interprets the spectrum display on your browser. Now think about this. So this is the flow of they wrote the actual applications in Python. And then there's no more work going on there. And then they hand off the user agent to OpenWebRx.js JavaScript to handle on the browser.
Question, this unit has to compare to the SDR play.
Oh, this is compatible with it. So I can take the SDR and plug it right in. It works.
Is it the same bit rate or?
It replaces the dongle.
Yeah, but is it better? It's 16-bit
It's
or?
better, yeah. SDR Play is much better than the 8-bit dongle. So that's what it replaces, that silver cylindrical, not cylindrical. But it replaces that. The Play just replaces that. You're using the OpenWebRx Plus software. So all the software is done by this, and it's using your Play as a DSP dongle. Okay, so there's significant advantages of doing this, and there's some disadvantages. So this is what it looks like. You get a spectrum waterfall. On your right, you set your frequency. You'll have it says that it's an RTL SDR. That's your 8-bit dongle, and it's set up for the 2-meter amateur band, and it's in narrowband FM. You can see the streaks. That's your signal. So I'm watching signals in this.
That's the whole band?
It's a 2-meter band.
Yeah, the whole 2-meter,
Yeah, from
amateur band?
145 to 147. So that's that slice of the band, yeah. But here's the treat for today. The treat for today is, since I'm able to separate the browser from the SDR sitting separated everything. So I got this thing hanging on my Wi-Fi and I can get my signals out of the firewall. I have to find that. All I have to do is type in the website for this tiny puppy sitting in my lab. Also known as a ham shack. You see the size of the zero though. See how small that is? It's yeah. So you see how small it is compared to a quarter. Anyhow, so that's sitting there. Now I'm talking to it on what's coming in as the RF from the antenna. And here we go. So here we are in real time. So if I want to take
It's real time right now.
right now is real time. So if I'm looking at the 10-meter band and I want to look at if there's any FT4 traffic, I can click on the bookmark at the top, FT4. Just, okay, see those trails here? Let me turn the volume on. See the data being demodulated. Let me turn this so it's a little clearer. Really looking at it from my perspective in Hamilton Square, with the antenna that's on my roof. This is this is the signals you're seeing. Now you notice this is the broader spectrum. The top is the broader spectrum. And then what happens here is you have a small 200 Hz window where you're seeing the individual signals. Now, some of these are hardly seen, like this is hardly even seen. We work below noise floor, slightly below. We work at the thermal noise floor. And with some of these codes, like if this is, what did I say this was? This is 10 meter and I clicked on FT4. So if you're a ham radio operator, FT4 is one of the Joe Taylor protocols that works. That works at very low signal levels. So this is then it demodulates it and says, okay, so this is the signals in real time occurring now on that you can click any of these blue underlined and you'll find out the links back into the call sign directory. So I can tell where that ham is from and what they're sending. Now FT4 are little snippets of information. Now, one of the protocols I like, well, Whisper is one that I've been using for balloon tracking. We have a student project here that I was an advisor for that we were doing balloon tracking. And I said, hey, let's use Whisper for that. Well, Whisper is pretty cool because you can get all over the world, you know. So I clicked on Whisper here. We're gonna see it. Yeah.
Go back to the FT4 traces again.
Yeah, now
Second.
clicking up at the FT4.
Yeah, now those traces, they're directly under parts of the spectrum? Is that where those signals are, or is that just somewhere else?
So this is a window,
Right,
a 200 Hz.
but it's not, like, some of these are not below 27.5 megahertz.
Well, no, where it's sitting is at the.
Is up there.
The legal FT.
Yeah, I just wondered, so it just happens to be the window is below
Right,
the 10 meter band. Okay,
right.
got it.
So if I wanted slow scan TV, I could click on that bookmark and look at slow scan TV.
Thank you.
Not bad for a $15. It's crazy.
Could you do that with the Airspy as well?
Yeah.
Yeah.
Yeah, it plugs right in. Beautiful stuff.
Yeah, I have a robot 1200C from slow scan.
Way back.
It's a paperweight now.
Yeah, you don't use it up. But okay, so let's just take a quick look at ham. So this is in a cluster of ham protocols at 28. The 10 meter band. So this is where JS8 calls. So JS8 call is kind of interesting to me because now I'm using it in a form like chat. I can tell you saying not only how good's the weather in my area, but we can talk about his health. We could, you can chat like you're on a chat window on the internet. So I like JS8 call, and Vara is another protocol like that. But this supports JS8 call. It supports a million all these protocols, incredible number of protocols it supports. Now these are just ham radio protocols, but since I said this is a spectrum display, check it out. So I've set up different bands. So let's suppose I want to see what's the latest aircraft over our heads right now. Well, look what I watch this. So watch this. So I tell my dongle to tune to 1090 with this profile. And then I click on ADSB, which is anybody a pilot in this group? ADSB is like.
This meeting is being recorded.
ADSB is 2 or 3 generations behind ACARS. So it's very much the latest protocol for tracking airplanes. So if you're bored of ham radio, you take the same product and you switch it to, notice I switched to 1090 and I had a profile and I have a bookmark on ADSB. And then here's the window that opens up. So you got in real time.
Wow.
I don't know if you can see this, but this is cool. You got flight ID. These are all linked, right? Aircraft is linked. If I clicked on this right now, I go to the flight internet database. Let's click on it. But now I can track this first flight. Because it said, by the way, it says it's only 5 kilometers away from me. So this is a small craft. This is en route to Johnstown, PA. And then this is called FlightAware. So FlightAware tells me, let me show you.
Lower. There you go.
Yeah, there we go. Okay, yeah, sorry. So this tells me And if I want to see if this is taking off or landing, it looks like it's coming into central Jersey right now, which explains why we got such a strong signal. It really literally is over our heads right now. It's handy for drone tracking too. But if you look at flight, this is linked to the internet-based. Watch this. This is cool. So now it's got plots from the ACARS data, the telemetry data. So it's actually plotting. This is actually giving you a plot of the velocity of the plane and the altitude of the plane. So you could see how long it took that little plane. It took it a while to get the full height. Jeez, a little struggling in here. Huh? But you see the flight pattern here. Here's the altitude. It's 7,300 feet. Well, he's not that high. He's 174 miles an hour, so he's like a turtle. But this is all linked to the real time direct from the airplane signal, which is pretty cool. Yeah. And like I say, this is just I had a speech today on tracking aircraft. So I went through this and there's like 7 aircraft protocols, wireless protocols that you can monitor. And the only one that's seriously encrypted is the global. Let me give you this one. This is a good one. This is something I'm interested in. I'm trying to find out more about how to use it. Okay, so this is one protocol. But this is a protocol list. So the first one that's listed is ACARS, which is a Gen 1 of aircraft tracking. And it works. So we'll go to ACARS. And I switch to the ACARS frequency plan. And I go to an ACARS. Where's a busy ACARS? Kind of busy, huh?
What was the mode you were just talking about that you said is seriously?
Yeah, so you can see ACARS. Well, I'm sorry,
What was the mode you were talking about? Seriously encrypted?
Oh, yeah, I'll get right to that. I'll show you that one. Now, I started learning, there's a couple interesting books. There's one guy, he's a professional pilot all his life, and he likes this technology. He's been writing his own Linux distributions. And he's a professional pilot. He likes tracking everything over the air. The guy's name is Philip Collier. And the book is Airband radio on the RTL SDR. Oh, that's the dongle, right? And it's kind of a cute book. It's a thin book. It's like $10. It's not an expensive book. And you get the even cheaper version of the. Anyhow, he goes into some details, and this is really an acronym soup. So ACARS is an acronym for Aircraft Communications Reporting and Addressing Systems.
And that's been around for like decades, right?
Yeah, beginning. I mean, that's the earliest. It's digital, but it's still working on our audio channel with using audio modulation. Next generation is VDL. VDL called VHF data link. And now VDL2 is the hottest VDL. And you'll see there's a lot more traffic on VDL than even ACARS. So that's the next generation's VDL2 is mode 2 for. And what they did is improve the data rates and the scalability of it. So you can have multiple planes overhead and they don't interfere at all. So VDL mode 2 will eventually replace ACARS, according to Philip. So this gives you some idea of real time. Now, what you see in ACARS and VDL, you see the same kind. In fact, VDL calls it ACARS, the text file. But see, this is a pilot typed this in. What is he complaining about? Birds, right? I guess it's pretty serious to have cranes in your engine. Yeah. But whatever this can be a hard show. I mean, when I was putting some of these slides together, I was watching this thing on the background, and I had it on my 65-inch monitor, and I start seeing things like engine failure. And the pilot is typing it in because you can see that our machines are going. Like this looks like telemetry. These are mostly telemetry here. But when they're talking about surfaces wet, birds, cranes getting stuck in the engine possibly, then the pilot's sitting there typing it on his computer. And this is going obviously for the control tower at sea. And other aircraft can monitor this. So if you, anyhow, there's a lot of interesting stuff. When I see engine failure, I start getting nervous, but pilots tell me, don't worry about it, you know.
Guess you don't need to worry about it till they start saying.
You get nervous.
engine failure.
Takeoff. I guess is it landing or takeoff is more dangerous?
What, for engine failure? Probably takeoff.
Yeah. Yeah, because you
All
got
the
your
thrust.
critical lift rate, yeah. I've been learning stuff, you know, this is pretty curious, this is like insane. You could get lost in all
What was
this.
that mode again you were talking about that's seriously encrypted?
Right, let's talk about that one. Because that's the one that's most interesting to me.
It's HF?
Well, it's HF, it's called the HF Global Command. Or Global Communication System, HF, High Frequency Global Command System. Here's what's cool about this. So think about, we go to a nuclear war with Russia. No such thing, right? What infrastructure are you gonna count on?
HF?
Yeah, you can't count on satellites. I mean,
Yeah.
Chinese can blow them out and time for a few other satellites to take out more than one. Is HF, is exactly right. High frequency is nature's satellite because it's bouncing off the ionosphere. So what they do is they want this infrastructure proof. So they have approximately, last count I saw was like 45 across the entire United States, including Alaska, Hawaii and so forth, like 45 sites that they are receiving this encrypted message. So it's single sideband, it's a voice. The voice will come on, and they identify what Dover airport, whatever the airport they just left. And the next thing you'll hear is a series of numbers. Like 502, much slower than I'm saying. So there'll be, I believe it's 40 characters. So somebody's talking about these numbers. So the numbering system is the only secure thing known on God's green earth. And it's called a one-time pad. They're using a verbal one-time pad to communicate. Now, these are nuclear missile, these are nuclear Air Force bombers. So when they get up in the air and they're on standby, there's a community of hobbyists that are tracking all nuclear bombers to see, you know, did they dispatch 10 from Dover or did they critical? I don't know whether they're critical, but they know that the critical launch sites are, and they know where the jets are, where the protective jets are, and the bombers, the rogue bombers, the nuclear tip bombers. And as far as I know, you can't read the encrypted site, but you sure know which plane it is. You have the plane ID.
So how does this differ from the old Strategic Air Command, the SAC stuff, the old Sky King messages do not answer? It's the same thing?
Same
They
thing.
just call it something else now?
Yeah, they should call it Curtis LeMay, you know.
Bomb them all.
Well, they have to- Curtis LeMay was a he never saw anything he didn't want to bomb the hell out of it. And he didn't want to bomb it, he wanted to use nuclear weapons.
Yeah,
Like, you know.
China.
He's a suspect on Kennedy's hit list because Kennedy wouldn't bomb both things, Cuban Missile Crisis, and he wouldn't bomb the Cuban Bay of Pigs. And he says, look, President, I have the nuclear bombs on bombers, the nuclear armed bombers ready to go. We'll take out all of Cuba. Then no problem. We'll blow the hell out of Cuba. All I need is your word. And he says, like, get out of here, you know. Are you kidding me? Hey, that was Curtis LeMay. He's famous for his firebombs during World War II in Tokyo. Yeah. He got a kick. He just designed a typhoon, heat-based typhoon that would fry anything and everybody in an entire city. He designed it. Figured out how to cook everybody. Nice guy. As long as he had a cigar, I guess he was okay.
Sometimes a cigar is just a cigar.
I did a history lesson on Cuban Missile Crisis, yeah.
We have about 5 minutes left.
Okay, let me get through. But anyhow, it's a good question because that's something I want to pay more attention. There are people on X that are tracking it as far as the frequency. You know, they're doing, a guy, I'm trying to think his name is, Gordon, will come to me in a minute. But yeah, there's a guy during World War II that worked at the, Bletchley Park. And he says this is valuable information. Even if the equipment the message is encrypted, I'm happy to know who's originating the message. So he did a frequency and a kind of like velocity type of messaging per hour over North Africa, for example. He knew something was going to happen in North Africa. These are Nazi messages, whether you could read it or not.
Just like traffic analysis.
He invented it. Gordon Welchman invented traffic analysis. Now the same kind of traffic analysis that the CIA uses and NSA use. He was the guy that did that. He was Bletchley Park, and he had moved to, at the end of the war, they told him burn everything. And then he said, I'm going to the States. He moved to Massachusetts. He was on the faculty at MIT. He designed the first computer at MIT. And then he went to work for the military as a consultant. And then they got really pissed off at Oldest Clearance because he published a book on it. And it's, I don't know how many years, 30 years later, you know, there's a British Secrecy Act. You can't talk about it even if it's 30 years ago. But yeah, it was interesting guy, you know. But, okay, so this is that. I'm gonna pay attention on that if you're interested in tracking that. Let's see what other goes.
Great stuff.
Yeah, it's really interesting.
What is that receiver RFI Open Web RX in the top left corner there? Go back. There's some.
Oh, that's mine.
What is that thing?
It's this big.
No, top left corner, there was just an image when you on the previous frame,
Oh, okay, I'll go back to that.
right next to where it said Open Web RX.
Okay.
The Open Web RX. It was there like 30 seconds ago.
Yeah,
Yeah.
here we go. Okay.
What is that next to the Open RX? What is that piece of
Oh, I
equipment?
took a picture of an old radio head.
But you don't know what it is? Okay.
Yeah, it's HR 500.
Okay, an old HF.
Solid state communications receiver ever built.
Got it.
And I restore old equipment.
Beauty.
Oh, you do?
Yeah, I like to do that.
I got a question.
Okay, all right, so let me wrap this up. I'm gonna be the last feature I can read. Yeah, I'm gonna start screaming. Were you there, man? Yeah, she's like, you're gonna die if you don't get out of here. What she said? Oh.
Curtis Millay of
I'm looking
TCF.
at her. You see her, okay, I'm out of here. Yeah.
This stuff is getting really good, these with the SDRs.
Yeah.
What do you see next? What's the next tier of technology that you see they're working on?
The transmit side.
Okay,
Yeah. It's- they need to look in the transmit side.
Did the plain lanyard crash?
A lot of problems with transmitting with SDR. Yeah. And,
I just saw its altitude drop.
yeah, this is great stuff, though. Let's see here. So what, these are a million other protocols. So if you like AIS is ship. So we're not seeing a lot of ship traffic because we're out of, you'll get some, but are moving to the shore. Ship traffic, AIS is called automatic identification of ship traffic. So what the ship is 200-ton vessels and larger could continuously send their position out. They transmit their position, they send their manifest, so you get a glimpse of it. Sometimes they'll talk about what they're carrying and like, for example, here's two signals that just came in from the Coast Guard coast stations. But as you get closer to the shore, you got, what did I say, 30 to 50 mile radius. So we're just outside of the Jersey coast range. When you get close to Jersey, this thing lights up. You bring it to Chesapeake Bay and it just floods. All kinds of signals. And then next to that, all these lines are NOAA. So these are 7 weather frequencies that you can see, and it's pretty cool.
you're getting a lot of them.
Yeah. So you get 7th NOAA. What is this first one?
Wow.
NOAA 1 for NOAA 7.
Nice.
And then there. Okay, that's it.
And temperature 59 degrees at 20 nautical miles south of.
But you can do all this for like with a couple $100, right? Assuming you have a computer.
Under $100.
Yeah,
No, you're.
with just a wire antenna, yeah.
Computer's $15.
Right.
Now, I paid $8 for a housing. I wanted a metal house.
Uh-huh.
Not the $8. And then the dongle was $30, 35. If you shop around, you get the V3 dongle.
Temperature 45 degrees.
For a ham club, you know, we were talking about the ham club earlier. This would make a good workshop. I would like to turn this, you know, you build them for $60, $70.
Amazing.
68 degrees.
And if you want to put them online, now here's the one thing, let me tell you real fast. What's my time?
What's reported?
Shut off, you're done.
The temperature was 70 degrees.
All right, let's
The
go.
report from Central.
Turn off the,
Available.
Here you go.
Okay, so,
Web SDR, you show that? Without spending a dime, you can use other
so
people's.
yeah, what I'm suggesting is, you know, this would be a fun workshop, like an IEEE or some other workshop, ham club workshop. Because I literally took me about maybe an hour to put it together. Configuring it is what it takes an hour because the software is actually amazing. And these guys are wild. These guys are wild. They're just like, well, here's a protocol. We forgot this. Let's throw this in there. And now the owners of the site are saying, here's the source code, have a ball. So, I mean, it's not super stable code. So you can go back to a version that you know is super stable, but
It's free.
stuff is coming out every month, the new versions for the last 5 years. So it's amazing.
You talking about this program?
Yeah, Open Web,
RX.
RX Plus. There's two versions. Plus is the one version. The non-plus is actually more stable. The guy's a cool head. He's not gonna add anything unless he can test the hell out of
Can
it.
you wrap up to showing people like Web SDR or something without spending a dime? You can go to other people's SDRs around the
Sure,
world.
that's a good one. Okay.
Because it's free. Anybody can try that tonight.
So
when they go.
anybody could put this on their act as a server and open it up to the world. I've opened mine up, not so much to the world until I get my Linux box back on. Then I can open up, I get 20 users simultaneously with Linux. But a little Raspberry Pi, I could get 1 to 3 people. So, but I'll probably put both on, both the Raspberry Pi and a Linux box, an i7 box with Linux, yeah.
When you say 3 people, are they all listening to the same channel?
Yeah, no, they don't have to listen to the same
3
channel.
people listening to 3.
Right, yeah, it's unbelievable, isn't it?
Can you show that in a web browser though, what people could do at home tonight without spending a dime?
Oh, sure. Okay, without spending a dime, we go to another web page here.
It's like Web SDR or something.
Yeah. So you can look up for, let me see what site is here. Okay, so just go to Google and say, just tell Google I want to see, open web. Just say, I want to see open web. So here pops up, it says map of SDR receivers. So this is stuff is all online. This is kind of cool. So you can go by any part of any computer you want. And there's a lot more than this because Kiwa uses the same code. Kiwa SDR uses this code. So it says there's 1,046 sites here in let's go to a site in Budapest. Okay, so where do you want to go in
A
Budapest?
lot of hobbyists.
A lot of crazy hobby. Okay, so here comes a,
Ukraine.
oh gosh.
Is somebody using an antenna and a radio
Always watching.
Yes.
and this software, and we can go into there?
Yes.
Yeah, so you're
There's a
watching,
radio in Ukraine right now.
so watching all the Ukrainian radio stations in this window here.
Unbelievable.
So you could monitor military traffic right now in Ukraine from your seat here.
Military traffic on Whisper, the Whisper ham protocol. I see troop movement. I'm seeing tank movement on this thing. I'm like, what the hell? You know, I mean, this is how to do things on a budget, right? So they're using Whisper, which works everywhere. And but you can only send very small messages. Perfect. I'm just telling an asset in Ukraine, I'm delivering it, boom, boom, give an asset a number. And then they start describing it, you know what the hell it is. Except I don't know if it's Ukraine or Russia.
Yeah.
I don't know. It's amazing how many Russians live in Ukraine.
Yeah.
And how many Ukrainians live in Russia. It's just crazy. I don't know. And if my earlier talk, they're using that for World War III. It's a testing ground for drones.
Oh, sure.
The drones are back and forth. It's literally in the Ukraine is being supplied by drones from Turkey, from China, all around the world. They're saying, test my drone. Here, you get it free. Try it out. See how many people you can kill. A lot of these are not kinetic. They're signal intelligence, I want to know where these people are. Yeah, there's a bunch of sites like you can. So you just type in online SDR.
Type in what?
What's that?
So we're a little bit out of time, Mr. Jessen.
A little bit or a lot?
We're over. We're over.
Okay.
You're about to
generous.
die
Thank
again,
you.
too.
Oh, no.